Welcome back, programmers. Guillaume here. In today's episode of the PureBasic 101 series, I will talk about data sections. They are used to embed data directly into your program, your exe file or your DLL. What for? Well, if you want to distribute a program, a software, you don't want to have one exe and then a lot of other external files like images, sounds, configuration files. You want to embed all of them within your exe file and just distribute one file. That's much easier. And you do that with data sections. Also, I have upgraded my PureBasic cheat sheet. Check out the link in the description. It's now a 2-page document with more information about PureBasic. So, data sections, let's have a look. Okay, so data sections let you embed data directly into your executable or DLL. You write a data section, you put data in your data section, and all the data will be embedded into your binary file. Pros, there is one pro, is that when you distribute your exe file or your DLL, you don't need to distribute external files with it. Everything is included within the file, the single file that you are distributing. The cons, on the other hand, is that the binary file gets bigger, of course, because you are embedding data within this binary file, so it gets bigger. And the second thing is that in memory it will take twice the space, twice as much space as it would with the files aside. Why? It's because the data is embedded in the code, in the binary code, plus you need to load it in memory. So you load it once when you load the code, the executable code, you load it in memory to be able to run it. You load the code in memory, that's one. And then when you load from the code to when you catch it or when you do the read, so when you read the data within a variable, you load it a second time in the memory. So it takes twice as much space as it would have if you would have put the files on the side. Okay, so let's go. How does this work? Well, there is this data section keyword that you use to start a data section. And you end the data section with an end data section, of course. So everything within the data section and data section is data. How do you put data? There are many ways to put data in a data section and read data from a data section. Let's have a look at some of the ways, at all of the ways, not some. Let's have a look at all of those ways. So first, you can put unitary data. When I say unitary, you put one value after the other with the data keyword like this. So data.type, and then values separated with commas or not. You can put on one per line or many, just as if you were defining variables. You are defining values like this. Data.q, data.d for doubles. Here I have 2 quads, 2 doubles, and 4 strings. And you need to put a label here. It's not mandatory, but basically you cannot work without the label, so it's kind of mandatory. It will not raise an error if you don't put a label, but you won't be able to use the data. So you have to put a label here to basically, when you are going to read the data, you will see you need the label to say, okay, I'm going to start here, and then you put the data. So as I said, first way of putting data is just by putting unitary data like this with the data keyword. Let's have a look at how we can read this data. So first example, to read values one by one with the data, you need to position the read head, just like a tape, okay? The read head to the beginning by using the restore keyword, the restore command, and then you call the read to read each value, each data. So here, for example, I'm defining an integer, a float, a double, and some text, a string. I'm calling restore some values. So if I go back into my data section, you see there is a label here, some values. So I'm restoring here, meaning I'm going to put the read head at the first value, the first piece of data that is after the label. The label is just an address basically. So restore some values, and then I read. So first I'm reading the first quad. I put that into this quad here, the in, and I'm displaying it. I'm reading the second quad, putting the value in the same variable because I just want to display it, debugging. Then I'm reading the two doubles here. Then I'm reading the for text every time I read, and then I debug, so I display it. And you see that read.q, you have to specify the type that you're reading, and the type must match the type of the variable. Otherwise, you might have some weird behavior trying to read a string into a double or a quad into a float. This will give you some result, but not what you expect. So doing that should display all the data in my some values. So I stop after the for string, so I should display 8 lines each, this, etc. Let's run this. Okay, so you see, I see my data here. Each line, it's the new data, 2 quads, 2 doubles, and my 4 strings. Okay, so that's the first way of doing that. We could have done a little bit better by, and it's quick optimization, nothing related to the data section, but I could have written a macro here quickly. And by the way, you see I've discovered this semicolon curly bracket that lets you fold. Okay, if you put a semicolon curly bracket, opening curly bracket, and semicolon closing curly bracket, it creates a folding section here that you can fold right there. Very useful. So okay, so if I uncomment this, I created the macro read and debug. I pass the variable, I pass the type, and then I do read.type type variable, and I debug the variable. So read and debug. I'm defining the 3 variables again, restoring some values again. So once again, back to the data section, I put back the reading head, the read head right here, and I start to read. Each time I call read, the read head moves to the next. Okay, if I read 8 bytes and a quad, it will move 8 bytes and get ready to read the next. Read and debug, read and debug. So I do the same here. Let's have a look. It displays exactly the same. It is the same data. That works. So just a quick piece of code with macros, and you see that you can use the macro like this, read.type, and this works. Okay. You can write data like this, but you can also include a file that will contain the equivalent, the same text as this guy. Okay, so here I created a hw hello world hw.pbi. The file is right here, and it's just one line, data.s, with the same 4 strings, just exactly the same line, except that I'm calling include file to include the data. So this include file includes the content of the hw.pbi file. So this exact, if I were to copy paste this here, that would be exactly the result. So include file here, and I put that under the label some strings from file. So let's have a look at this example here. I'm defining a sentence, an index. I'm restoring some strings from file. Okay, some strings from file, this label. And then I know I have 4 string, so I'm iterating from 1 to 4. I'm reading the next string and I'm concatenating to the sentence, and I will just display the sentence. That should be. That doesn't work because I have not defined my text here. And there is no $sign. Let me put this like this, sorry. Boom, hello world. Yes, hello, comma, world, exclamation point. That was in my file, hello, comma, world, exclamation point. I should put a space right here to make it work, to make, see, the exact punctuation here. Hello world. Perfect. So you can include data just like data, but with including a file that contains the data. Sometimes it's better for separating your data from your code file to put that into a file. Another type of file that you can include is binary files. So the rest of the explanations down there is, most of them are binary files. So I have created two binary files. So let's have a look at those files. I'm using the file viewer here. I have a data bin, and I will open directly the data2 bin. Okay, data bin is just a binary file, and what I did is so we can see that here I wrote some text, and first I've put a quad, which is the size of the text, and then I've written some text. This is a nice text. That's the content of my file. I make sure that the string ends with a \0, so a 0000 character, to be sure that when I'm going to read it, I'm going to have the correct length for my string. So, and I'm including the file using include data.include binary, so EOS for end of string, include binary data.bin. This file, I'm including the data binary just as is in my data section, and I can read that as I want. I can use read calls to read the first quad, because I know the first part of this file is a quad, and then I know the rest is a string, so I can use it like this. So my next example here is exactly that. I have this example 3 here, not the 4th. Here I'm defining a quad and a text. I'm restoring EOS, this label, so I'm putting the read head really at the beginning of the binary data that has been included right at this label here. And I start to read. I'm reading a quad, and then I'm reading the text, and then I'm displaying both of them. Boom, 19, and this is a nice text. Everything is nice. I have my quad, which is the actual length of the string, and I have my text. Perfect. But you'll see that, as I told you, the string in the file must end with this /0 here, 00, because it's Unicode, to tell the read.s that it is the end of the string, that it must stop after this /0. So I'm going to show you the counter example here, the example that doesn't work. I have the data2.bin, and the data2.bin, I've written the same text, but there is no, see, the last character is supposed to be this 7400, which is the T, and after I'm putting 8 bytes, so quad, with 19, the length, and the 00, which is the end of file. But here, after the last character, I don't have any 00 to tell that it is the end of the string. And so when I'm going to read the text, I'm going to stop actually here. This is going to be expressed as a interpreted as a character. So this doesn't work. So let me uncomment this piece of code here. So here, same thing, quad text. I'm restoring no EOS. The no EOS is here. I'm including the binary data2.bin. And when I try to read, I first try to read the text, then debugging it, and then I try to read the size. I think I'm here, but actually I'm there. And when I'm reading the quad, it gives me something weird. Let's have a look at that. Boom. This is a nice text. Well, there is an extra character here that we don't want. Plus, the size is completely nuts. It's not 19 at all. So this doesn't work. Make sure that your file, your text, when you're doing that, ends with this 00 character. For your information, I did that using this little piece of code. This is an iText. So the data.bin, I'm writing the quad, and to write the 0, I'm using write data, and I'm making sure that I'm writing the length of the text plus 1 to include the 00, okay? Because if you use for the data2.bin, I use write string, and the write string command in PureBasic doesn't write the ending, the trailing \0, the trailing 00 here, and so you end up in a file without it. So something you need to know. Okay, that's including binary and reading using the read and restore. Okay, so it's already a lot of ways to read data from your data section. But you can include, there is another way, you can catch the data. So you have many procedures, commands in PureBasic to catch the data depending on what type of data you have put with your include binary. So you can catch data, you can load images, sprites, sounds, tracker music, JSON or XML files at once. So just one command will get, it's as if you were loading your file, but instead of loading from a file, you load from a data section. So here, all the prototypes, the declarations of all these commands. So in your data section, you just need, so there's a little trick here. You need to have a label for the beginning, but you also need, it's better to have a label for the end. So for example, here I'm including a picture, cat.jpg. I'm including a sound, some OGG sound file, okay? I'm including a JSON file. I'm including a contact and XML file. I will show you the content of those files. For the image, cat.jpg, okay? It's a picture of a cat. How do you read that? Well, you don't read really, you catch it, okay? So to catch, you just call catch image. So here I'm defining a new image, catch image, pbne. So the catch image will return the image ID, well, the image ID, the image handle. And then I need to pass the memory address and the size. Memory address is the address of the label, okay, the image label here, image. So the address of this label is basically the same as the address of the first bytes of the binary data that represents the JPEG file. So the question mark here is used, to return the address of a label, the address in memory of a label. And you see here, to get the size of the image, I'm subtracting the address of the image from the address of the end image. Let's have a look. End image is the label after the data. Image is the label before the data. So if I subtract the two addresses, this minus this, I get the size of the data that is being included by this include binary. So the size that the catch image command must read. And that's how I get the image. And then this piece of code just to display, to show you that it works. Let's run this. Boom! Look at that. Very nice. Window and a little picture of a cat. So that works. I'm able to load the image directly from the data section. You can do the same with a sprite. So it's no different, except that instead of catching the image, I'm catching a sprite. It returns a sprite and I can display it in a screen. So here I open a window screen, I'm catching my sprite. Same thing here. So here the catch sprite doesn't have a size. It will trust the fact that the file is okay, and it will just read until it reaches the end of the image file. Same thing for the image. By the way, you could use it without the size. Is not mandatory, it's optional. You can use it without the size. But it's safer to use the size to be sure that you are reading just the correct amount of data. If the file is corrupted somewhere, you can end up crashing your application. The fact is that with the catch sprite, there is no size. So I'm just passing the address of the image. So I'm loading the same cat.jpg image, but as a sprite, with the alpha blending. And here I am doing the loop, flipping buffer, displaying the sprite, and waiting for the close event. Let's have a look at this. Boom! Et voila! We have the same image of the cat that is displayed, but this time it is displayed as a sprite. And you may think you can already imagine the rest. We can do the same for binary data to load sounds. So here, what do? Control. I'm catching a sound at the label address sound with the size and sound minus sound. Let's have a look. Here I've included the music.ogg between sound and end sound. So I'm going to load this OGG file and I'm going to play it. Then display a message requester so we can stop it. That works. So same thing, catch sound to catch a sound in the data section. And you can do the same. It's not binary data, but it's text data, JSON format, okay, for JavaScript format, and XML files. So here I have two files, contact.json. Look at that. It's just a contact, first name, last name, age, address, phone numbers. So you'll see we can read all this at once by using catch JSON. Okay, so here the example. First, I'm including between JSON and end.json labels, I'm including binary data, contact.json. And so I can catch this data. So here, catch JSON, same thing, JSON address, and JSON minus JSON to get the size, PBNE, this returns this JSON, JS handle. And then I'm defining a contact. So here I have defined the structures that match the actual format of this file. So I have a structure contact. Within it, First name, last name is live age, address. Address is itself a structure with street address, city, etc. Phone numbers is a list of structures called phone number with type and number. Okay, so address here, phone number, type, number, and structure contact with the fields, an address, and a list of phone numbers. And I'm calling here extract JSON structure. I'm getting the JSON value. I'll do a specific video on JSON and XML, but extract JSON structure will read from the JS here within the contact variable using the contact structure here. And just calling this will actually read from the JSON that has been parsed using the catch JSON. And I'm just displaying some of the information here, first name, last name, city, and the number of phone numbers to show you that the list is actually working. F5 here. John Smith lives in New York and has 2 phone numbers. Is that correct? John Smith lives in New York and has 1 and 2 phone numbers. So that works, that reads the JSON correctly. And finally, we can do exactly the same with XML. So here I'm keeping the structures because it's the same. The only difference here, and I'll do a specific video on XML, I don't know it really yet, but what I had to modify to make it work is that instead of having phone number here, I need to have this XML called element, because the phone numbers will be a list and this is the element of the list. Okay, so I had to do that to make it work, but here I'm catching the XML exactly the same way using the XML and end XML minus XML to get the size. Once again, XML label and XML, and inside the include binary of my contact.xml. So here I'm catching the XML inside this variable. I'm defining a contact, I'm extracting an XML structure exactly as I did with the JSON, and then I'm displaying the same information. Let's run this. Jane Doe lives in New York and has 2 phone numbers. Is that correct? Yes, I changed it a little bit to show you that it works. Jane Doe lives in New York and has 1 and 2 phone numbers. That does work. And that is it for data sections. And voila, that's it for data sections. Now you know how to embed any data in your exe files and distribute only one file. As usual, if you enjoyed this video, drop a like. You can subscribe right here. You can check out the social media right there and the latest video right here. Also, merchandising, you can buy yourself a nice t-shirt like this. Check out the link in the description. Thank you all for watching. I will see you soon.